film documents the end of the first year of the Tailor Robot Pi project, undertaken by the University of Manchester's Science and Engineering Education Research and Innovation Hub.
Quite excited to hear what the other groups of schools have been up to.
I think the learning style's completely different to anything that we've really done before.
There's lots more that we can do in terms of the project.
I think it will be interesting looking at the way we've moved from the control side, from the computing, to actually more practical elements of the curriculum.
10-year-olds actually working in Python, and even though some of them are not gifted and talented, some of them are just below average, and they're still actually doing it really well.
In our opinion, there's no point of just doing it for a set of 30 children. We wanted it to have an impact on the whole school community.
We're talking on the use of computing with the tinkering there as well, so myself and Nicola are going to explain what we've done with the robots.
We're focusing on how primary computing was used to do the Tailor Robot Pi project. Our robots did a dancing competition.
Yeah.
And it was creative in the sense that the children wrote music for the robots to dance to, and the children wrote the dance routines that the robots did.
Yeah.
But it was more technical, I suppose, than creative in that sense.
Yeah. Again, we've got about 92% EAL in school as well, so the communication, the reasoning skills have really kind of gone through the roof with this.
We get children, and girls particularly, choosing their options in Year 9 who do go quite heavily down the traditional routes, and we don't get many girls going into engineering or technology-related subjects.
It was amazing how much interest actually there is in engineering, but a lot of people don't know actually what an engineer does.
Because I think that young people, especially girls, need to be encouraged to look at engineering as a career, and that's the whole thing, isn't it, behind Royal Academy getting involved.
I think there is more opportunity to continue to focus on this problem finding. I really do like that.
What this project has allowed you to do is step outside of the curriculum and just look at one area and really research it and look at how it works and how it impacts. Lots of secondary schools never step inside a primary school, and I think this project allows you to go inside the primary school and actually look at the quality of work that's being produced.
We're here at the Royal Academy of Engineering to join with colleagues from the Thinking Like an Engineer project, run by Bill Lucas and Janet Hanson at the University of Winchester.
STEM education, as we often talk about it, is kind of largely devoid of technology and engineering. It's usually a focus on science and maths, but the engineering is where it's all brought alive. I mean, it's really exciting stuff, and I think we lose that in schools. We focus on the science, we focus on the maths because of the assessment system and all these kind of things, and yet actually, when we bring science and maths together with design and technology, with computing, that's when the creative juices flow and you get brilliant engineering.
But if you think about the impact within science even of reduced opportunities for experimentation, practical experimentation, the pressures certainly at GCSE level on doing any practical experimentation. I've been in and out of very good schools who tell me that the enemy is coverage. I've just got to do so much.
So success for me after 18 months of this project will be that we've taken the very first steps towards a new way of teaching, because this is a big long project we've got. This is a big long problem to change the way we teach kids in school and to bring out creativity and problem solving, because the education system is so stacked against us right now, and we really have to develop and foster a new way of teaching so that engineering habits of mind, like visualizing, problem solving, improving, tinkering, all these things are really brought to the fore in our education system, because that will enthuse the kids, it will enthuse the teachers, and ultimately it will improve better grades.
So the project that we were working on was called Tailor Robot Pi, and that was to kind of incorporate these ideas of tinkering with robotics, and the Pi comes from Raspberry Pi. The pupils worked in small groups using the B-bots to visualise how the robots can move and to work out how well they wanted the robots to dance. Then the pupils worked in pairs using Scratch to create their dance routines. They visualised what the real robots were going to look like by using a photo on the computers. Then they worked together in their group to choose the best dance routine for their competition.
Just getting on to my point about engineering being a really exciting, rewarding career that young people should seriously consider. But they can only seriously consider it if they have a reasonably good understanding of what engineering is all about. And the sooner we start engaging with young people to inform them about the excitement of engineering, the better. And hence, starting at a young age, I think, is really important. What we've seen today from the teachers who have spoken about what they're doing in their schools is a very broad and exciting vision of the future of STEM education in schools.